The second type we're going to learn at grade 10 is called factoring by grouping. So I want you to call it number 2 and let me elaborate on what this is. It's a very simple idea, very similar to factoring out the HCF, but it's just a different idea, right? It's just a different technique. We will adopt this approach if we have an algebraic expression with 4 terms. Very, very important. Remember when we discussed factorization at grade 9? At the end of the video, I said HCF can be used for unlimited term, dots can be only used for 2 terms, and trinomials can only be used for 3 terms. What am I saying here? Under factoring by grouping, this can only be used for 4 terms. Very important. I want you to highlight that. And there is a common binomial factor that exists. Highlight this word, common binomial factor. Our aim is to factorize algebraic expressions with 4 terms into a product of 2 binomials. So if you just look here, just glance over here. When we're given the question, see 1, 2, 3, see what we end off with. Just 2 binomials, a product of 2 binomials. Our aim should be to get this complicated expression as a product of 2 binomials. Alright, so let's look at these questions. You see, when you look at the first question, you see this here, x plus 1 and x plus 1 are common binomial factor. It's common to this term and this term. So therefore, I can factor it out, right? So if I have to re-express it here, it's very similar to what we said for HCF. AB plus AC. See, A and A is the common binomial factor x plus 1. If I call that A and I call that A and I call that B and I call that C, then we can factor out the A. There's it here. So we're basically taking out the common binomial factors. Okay, I know I spoke about 4 terms. If we expand this here, you would see it would result in 4 terms. And if we expand that, there will be 2x squared plus 2x plus 3xy plus 3y. Right? Now, I promise you, when you're at grade 10 and you're given factoring by grouping in this form, many students cannot solve these questions. But by me telling you, you utilize this technique when you're given 4 terms, simplifies the process a lot. Because if you are given 4 terms, you are most likely going to use factoring by grouping. And that's the reason why, if you do this, and if you work this question mentally, you must be able to say, okay, in this term and this term, I have 2x as a HCF. So therefore, it'll be 2x into x plus 1. Then you'll say, okay, in this term and this term, I have 3y as a HCF. So 3y into x plus 1. Then I notice, oh, you know what? I actually have a common binomial factor. So therefore, I'm using factoring by grouping, and I can extract the common binomial factor as x plus 1 into 2x plus 3y. Right? Very simple. So you're just considering this bracket as a single term, and you're distributing this term into each of the terms in the other bracket. Right, so that's one type of question that you could be given. Let's look at another type of question. See here, you have 2x into x minus 1 plus 3y into 1 minus x. See here, you don't have a common binomial factor. So what we do is, and this is very important, you see in the brackets, watch here, I can say 1 minus x is the same as minus into x minus 1. Because if I say minus times a plus is what? Minus x. Minus times a minus is a plus 1. So therefore we have 1 minus x. We're basically extracting a minus 1. This is what we call the change of sign rule. By extracting out the negative, you can swap what you have in the brackets. So by taking out a negative, you can swap what you have in the brackets. The terms in the brackets, you can swap their position for this reason here. But when you're taking out the negative, this negative, you have to multiply it by what's in the front. Because it's similar to saying plus 3y times minus 1. So let me write it here. So you have 2x into x minus 1. Please write this down. Plus 3y times minus 1 into x minus 1. Right? So therefore you have 2x into x minus 1. Plus times a minus is a minus 3y into x minus 1. This is why we call it the change of sign rule. Because you change the sign from a positive to a negative, and you swap the position of what you have in the brackets. So here we swap the 1 in the x, and we change the sign of the term in the front there. Right? So therefore you have a common binomial factor that you can extract, and you have the product of two binomials. That's what we call factoring by grouping. Another question that you could be given is the common binomial factor is there, but you need a seed. Right, so look here. You have 2x into x plus 1 plus x plus 1. So if you group this here together, you have an invisible 1 in the front there. So you have 2x into x plus 1 into x plus 1. So therefore, it'll be 2x plus 1 in one bracket into x plus 1. Very, very simple. But you just have to see that the 1 is in the front of the bracket. So you obviously won't write that there, but this is why it's complicated, because you have to see that there's a 1 there. Okay? Now this is how you do factoring by grouping, our second type of factorization. And I basically gave you an entire list of every possible question that you could be given. So in an exam paper, you would either be given this, this, or this. Right? That's why you have to master these techniques. Okay, after considering all of these three different types of questions that you could be given, it's very important to remember that you could take any two terms and you will eventually find a common binomial factor. So let's say we were given this and I take the first and the third term. Then between the first and the third term, the HCF between the first and the third term is x into 2x plus 3y, right? And then we're left with plus 2x plus 3y, plus 2x plus 3y. Right, so now how are we able to factorize this using factoring by grouping? This is where it comes from, the third variation. So therefore what I can do is I can say it's x into 2x plus 3y plus 1 into 2x plus 3y. And we're able to simplify this into x plus 1 into 2x plus 3y. Right? So you can choose any two terms, but you just have to keep all of the other rules of factorization under factoring by grouping in mind, right, in order to ensure that you can solve these questions. Or you could have just solved it the exact way we did here, where we could say 2x into x plus 1. I'm taking the first two terms, and then I take the second two terms, which will be 3y into x plus 1. We have a common binomial factor, so therefore it'll be 2x plus 3y into x plus 1. Very, very simple. Right, so you can take any two terms, but like I said, see, like this becomes a bit more trickier when you can't actually see the common binomial factor. You can't actually see a distinct common binomial factor. You have to do some modification to it in order for you to see it.